Hey guys, so on this, let me just do this example so you can look at it and compare your work with mine. So the basketball was dropped from rest. That means before it went down, its initial velocity was 0 meters per second. Its acceleration, I'm using down as negative 9.8 meters per second squared. And displacement, since down is negative, in the first case it will be negative 1 meter. I do not know how long it takes to get there, but I can calculate it, and I do not know its final velocity just before it hits the ground, but I can calculate the final velocity using v1 squared equals v0 squared plus 2a delta x. So v1 squared will equal to 0 squared plus 2 negative 9.8 negative 1. If I take square root of 19.6, I can get my final velocity as it goes down. So you guys do that, you can get the square root. Now when it falls and then rebounds back to a height of 0.67. Just here when it falls, we've seen that its final velocity is 19.6 square root. And I know that when it's gone up back here, there's a time where it momentarily comes to rest. So its final velocity will be 0. I'm looking for its initial velocity at this point, which I do not know, but I know that its acceleration is still negative 9.8 meters per second. It's going up, but its acceleration is downward because acceleration due to gravity is downward, and my convention is that down is negative. Displacement is 0.67, but it's positive because up is positive for me. So I'm going to use the same formula, v1 squared equals v0 squared plus 2a delta x. v1 at this position is 0 because anything that you toss upwards momentarily stops before it starts falling back down. v0 is what I'm looking for. This is 2 times negative 9.8 times 0.67. So I can rearrange this and I have v0 equals 2 times 9.8 times 0.67, and v0 would be the square root of what I have there. You guys can do that too. Part C, if the ball is in contact with the floor, now they're giving me the time is 0.1 seconds. Determine its acceleration on the way down. Now acceleration on the way down is acceleration due to gravity, and I know that that's negative 9.8 meters per second squared. While it is in contact with the floor, now I know that acceleration by definition is change in velocity divided by the time. Change in velocity is v1 v0 divided by time. So the v1 just before v1 in this case is going to be after it has left the floor, and v0 will be just before it hits the floor. Just before it hits the floor, I hope you remember we calculated that speed as the square root of 19.6. And remember your convention. My convention is that down is negative, so that would be negative 19.6. Its v0 is just after it leaves the ground, the rebound speed, which is what you calculated here, square root of that value. So I'll subtract, it's going up, so it's positive, so I'll just leave it as positive. This is square root 19.6. Square root 19.6 times 0.67. All of this divided by the time, which is 0.10. This is going to give me a value for the acceleration as this ball bounces, that moment when it bounces and goes back up. I hope you realize you will find that this acceleration must be bigger than the acceleration due to gravity. The magnitude must be bigger than 9.8, because there is a huge change of velocity required to change direction. Like the change of velocity happening in order for you to be able to change direction has to be significant. So that is what the idea of acceleration is about. You have a negative velocity going down, and then you have a positive velocity going up. So there is some force that is interacting with this object here to give it that kind of change of direction. If it's giving it a change of direction, then that force is giving it an acceleration, which you're calculating here. So you guys can work it out. You have calculators, you can see what it is. It will be negative because your convention is that down is negative, but the magnitude of that acceleration is really what you're looking at. Acceleration on the way up, what do you think? On the way up, it is in free fall, and therefore it is under the influence of gravity, so its acceleration is still negative 9.8 meters per second squared. This thing won't right. Yeah, that's it.